Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution. Have you ever noticed how after 12 o'clock the clock comes back to 1 again? Like 13 doesn't exist on a clock, it becomes 1. This is exactly what we call modulo arithmetic. Hi everyone, today we are learning modular arithmetic, a very important concept not just for class 12 mathematics but also for competitive exams like JEE Mains plus Advanced, Olympiads, GATE and ND exam. So if you are preparing for any of these exams, this is one video you shouldn't skip. Now let us understand what is modulo arithmetic. Numbers wrapping around after a fixed value, and a clock is the best real life example of modulus 12. Now the word modulo means remainder that is left after the division. For example, if I want to divide 17 by 12, I get 1 as a quotient and 5 as the remainder. So we write 17 mod 12 is equal to 5. Remember, modulo just means remainder. Now, in any division, we have 4 things: dividend, divisor, quotient and remainder. Out of these, first 3 may be positive, negative. In fact, dividend and quotient both can be 0 as well. Only divisor cannot be 0 because otherwise the entire division becomes undefined. We cannot divide any number by 0, right? But main thing over here is the remainder. Remainder is always non-negative. That means it's either positive or 0. Obviously, always less than the divisor. Now, let us see few cases. Case 1, when we have positive dividend, how to evaluate modulus? Simple, divide and find remainder. For example, 42 mod 13. Here we will divide 42 by 13. Remainder is 3 and hence 3 is the answer. But what if the divisor 13 is negative? That is, what if I have 42 mod minus 13? In that case, you need to remember to ignore the sign of the divisor. Just ignore. So find out 42 mod 13, which is 3, and 3 is your answer. But what happens if our dividend is negative? In that case, let us take this example. First step is to ignore the sign and find remainder. So 42 mod 13 is 3. Now, in case of negative dividend, remember to subtract your answer from the divisor. Your divisor is 13. So I'll do 13 minus 3, which is 10. So here our answer is 10. Now what if both dividend and divisor is negative? We'll follow the same rule. For negative divisor, we'll ignore the sign, and for negative dividend, we'll subtract our answer from the divisor. For example, this. So step 1, ignore both the sign, find remainder. So here 42 mod 13 is 3. Now, as our dividend is negative, so I have to subtract 3 from the divisor 13. So 13 minus 3 is 10, and hence our answer over here is 10. Now, the next important edge case. Remember, while we were discussing the first one, I have clearly written over here when r is not equal to 0. But what to do if our remainder is 0? Remember, it stays 0. No changes needed. For example, minus 26 mod 13. So first we'll ignore the sign and divide, and we get remainder 0. So we don't need to do that second step. You don't have to subtract 0 from the divisor 13. So your answer will not be 13. Your answer will stay 0. Now, the next very interesting topic, congruence modulo. To understand this, let us try to evaluate the values of this. 17 mod 5, 12 mod 5, 7 mod 5. That means just divide these numbers by 5 and get the remainder. And here you will see each of these numbers will give me remainder 2. So since all of these numbers 17, 12, 7 as I have given gives the same remainder when divided by 5, we say 17 is congruent to 12 is congruent to 7 modulo 5. And yes, over here congruency between two numbers is denoted using three parallel lines. Now one more way to think about this is that the difference between any two congruent numbers will always be a multiple of 5 or divisible by 5. For example, if you take 17 minus 12 or 12 minus 7 or 17 minus 7, each of these differences you see are divisible by 5. So if we say A congruent to B modulo n, which means A minus B will be divisible by n, and since it's divisible by n, which means there will be an integer k such that A minus B is equal to nk. So A is equal to B plus nk. Now let us understand the group of numbers which leave the same remainder 2 when divided by 5. So let's say the first number is 2 itself. The second number will be 2 plus first multiple of 5. Next number 2 plus second multiple of 5. Just keep on adding the different multiple. All of these numbers will leave the same remainder as the first digit, that is 2. So 2, 7, then we are getting 12. Next number is obviously 17 and so on. Obviously the list is endless, and we can also go on the negative side. So we can go with 2 minus 5, then before that 2 minus 10 and so on. Because all of these numbers, just try dividing minus 8 by 5, you will see you will get the remainder 2. Remember our rule, just check it out. So which means they all belong to the same group, same class, we say, under modulo 5, because all of these numbers minus 8, 2, 7, 12, 17 gives the same remainder 2 when divided by 5. Now let us apply these questions, this concept to some questions like this. X congruent to 12 modulo 5. Now you know how to calculate 12 modulo 5, which is equal to 2. Now X is congruent to 12 modulo 5. What does this actually mean? It means X and 12 leaves the same remainder when divided by 5. Now remainder 12 modulo 5. So 12 leaves remainder 2 when divided by 5. So this question clearly means find those numbers which will leave remainder 2 when divided by 5. X are those values. So let us try to list a few values. If the first value is 2, you know you just have to do plus minus 5, multiples of 5, right? So it is an again endless set of numbers. So 2 plus 5, 7 plus 5, 12, you can go on, and in fact we can subtract also. So all these numbers will behave the same in modulo 5. So all of these are my solution. So remember, to find X we are using 12 plus 5k, where k is an integer. Again, why 5k? Because you know adding multiples of 5 will not change the remainder. Now, next question. 147 is congruent to 3 modulo m. So we have to find the modulo m. Here we cannot find the value of 3 mod m. So we will go other way around. Remember, if two numbers are congruent, which means their difference is going to be divisible by m. So 147 minus 3 must be divisible by m. That means 144 must be divisible by m. So what are those numbers which are divisible by m? Obviously the factors of 144. So m must be a factor of 144. Now since m is the modulo over here, m's value cannot be 1. M is an integer greater than 1. Okay. So possible values of m are all the factors of 144 except 1. Moving on to our next question, which is this. If 39 is congruent to x modulo 7, we have to find the set of values of x. Again, I hope you understand that 39 and x both leaves the same remainder when divided by 7. They are congruent numbers, which means their difference is going to be divisible by 7. So, we can write this in this way, equal to 7k, where k is an integer. So, x is equal to 39 minus 7k. Now, let us put different values of k, integral values of k, to get different values of x. So, the corresponding values of x are these, and that is the answer. Next topic, congruence class. Think of it like grouping students with the same marks. All the numbers that leaves the same remainder when divided by a particular number belongs to the same group. For example, we are working here in modulo 5. So that means when we divide any number by 5, the remainder can only be 0, 1, 2, 3 and 4. No other possibility, right? Now let's group numbers based on the remainders they give. So if I want to create a remainder 0 group, obviously all the multiples of 5 will be there in the group. Remainder 1 group will have -4, 1, 6, 11 and so on. Remainder 2 group, remainder 3 group, remainder 4 group. Now each of these groups is called a congruence class because all the numbers in the group behave the same in modulo 5. They look different, but in modulo 5 they are the same type of number because they give same remainder when divided by 5. Now, how do we denote all of these groups? Using square brackets. And we write inside the square bracket the smallest non-negative number, that is 0 over here. So the remainder itself. 0 modulo 5. The modulo number is always written as subscript. Similarly, remainder 1 group can be denoted like this, 1 and 5 over here. Remainder 2 group, remainder 3 group is denoted in this way. So any congruency class is denoted with a number written in between the square bracket. All of these says a set of numbers which gives the same remainder as 4 will do when divided by 5. That means all this number will give remainder 4 when divided by 5. Now, also we understand this, that each of these numbers in a particular class are congruent to each other. Like 9 is congruent to 14, 14 is congruent to 4, 14 is definitely not congruent to 3 under modulo 5, right? So they are congruent to each other, that is why they are belonging to the same class. Remember, in modulo 5, there are only 5 classes, no more, no less. So if it is modulo n, that means there could be only n classes, not more than that. So instead of thinking about infinite number, we just think in terms of 5 groups. Now tell me something. 7, 12, 2, all these belong to remainder 2 group, right? So instead of writing 7 within bracket or maybe 12 within bracket, why do we usually write 2? Because 7, 12, 17, all of these numbers will give me remainder 2 when divided by 5. Remember, we choose 2 because it is the smallest non-negative remainder. So think of it like giving a group a name. If many students are in a group, we don't call it by different names every time, right? We choose one simple standard name, maybe by house color, blue house, red house, or maybe by your class section, right? So every class has many numbers, but we prefer the one between 1 and 4 in mod 5, obviously. So if it is mod n, you always choose the numbers, the representative numbers between 0 and n minus 1. So instead of writing 7 or 12 within bracket, we write 2. Now, moving on to a property, A mod B is equal to A plus KB mod B. Now, I've already explained this. When we add multiple of the divisor to a dividend, the remainder stays the same. So suppose I know 8 mod 3. So 23 mod 3. Now since 23, we can obtain 23 by adding 5 times 3 to 8. So which means 8 and 23 are congruent to each other. How to check congruency? Just subtract 23 and 8 and check whether it's multiple of 3 or not. If yes, you don't even have to divide. You know that they will give the same remainder. So 23 minus 8 is 15, which is a multiple of 3, which means 23 and 8 are congruent numbers. So that means remainder is 2 over here. So 23 mod 3 will also give me 2. Now let us try to solve this question. Find the equivalence class of 3 mod 5. 3 mod 5 is equal to 3. So I need to find out all those numbers that will give me remainder 3 when divided by 5. So I'll use the previous property to get all those numbers. So I'll just do plus minus multiple of 5, and that gives me the entire set of numbers belonging to this congruence class. Now next question, it is currently 8 AM. What time in AM or PM will be in next 500 hours? Now we know in 12-hour clock, the time repeats after every 12 hours. But in digital clock, since we have to find the time in AM or PM, it's important that we do in 24-hour clock. So the time will repeat after every 24 hours. So we find out 500 modulo 24, which is 20 over here. So after every 24-hour clock, the clock will come back to the same position. So final step will be starting time is 8 AM. So we need to add 20 hours because we have found out 500 modulo 24 is 20. So that 20 hours needed to be added to 8 AM. For adding that, we will break 20 into 12 plus something. So over here 20 is 12 plus 8. So if I add 12 first to 8 AM, we'll get 8 PM. Then add the remaining 8 hours. So we get 4 AM. So after 500 hours, the time will be 4 AM. Now let's see how these properties actually help us solve big questions without long calculations. So let us see the first question. Find the remainder when sum of these numbers is divided by 3. Which means we have to find out sum of these modulars 3. But we are not going to add these big numbers. We will take each number modulo 3 and then add. So each number modulo 3 are these, and then we are going to add these remainders. So which is these. Now just add the small numbers. So sum of these numbers is 8 modulo 3, which is equal to 2. So see, big numbers reduced to small numbers. That's the power of modulo. Now let us see the second sum. Same idea, but with multiplication now. So I'll first see individual numbers modulo 3 first, which are these, except I've changed the first number because if I take the same number, I'm going to get 0 as my answer, because if one number is 0, the product of all of these numbers will give me 0, and hence I've changed this. So 674 modulo 3 is going to give me 2. So 2 into 1 into 2 into 1 into 2 into 2, which gives me 16 modulo 3. And 16 modulo 3 is 1. So again, small numbers, easy multiplication, right? So here the remainder will be 1. Now let us see the next question, where we have to find the last 2 digits of the product. Obviously, last 2 digits means modulo 100, because if you divide 2 numbers by 100, the remainder gives you the last 2 digits. So here 2, 3, 4, 5 modulo 100 and 6, 7, 8, 9 modulo 100 are 45 and 89 respectively. So we will multiply 45 and 89 here, which is 4005 modulo 100, and the last two digits if we divide is 05. So we ignored everything except last two digits. Huge shortcut, right? Now let's see how equal numbers behave in modulo. So we will see the use of these property. If A is congruent to B, then we can add any scalar on both sides, still the congruency remains. We can also multiply, we can even subtract. And if A is congruent to B mod n and C is congruent to D mod n, we can add them up. A plus C mod n will be equal to B plus D mod n, or AC mod n will be equal to BD mod n. That is, AC will be congruent to BD and A plus C will be congruent to B plus D. So congruency can be, modulo congruency can be added or multiplied or subtracted. So we will see the application of each of these. So let's say the first one. Suppose we know 7 is congruent to 12 mod 5, right? So can we add 3 to both sides and see whether the congruency still remains? Let's check it out. So 7 plus 3 gives me 10, and if we do mod 5, we are getting 0. And 12 plus 3 is equal to 15, and if we do mod 5, again we are getting 0. So same. So that means if two numbers are equal in modulo, adding same thing gives them equal. Now let us see whether multiplication behaves the same way. So we'll use the same example. So 7 multiplied by 2. Now we are multiplying by 2. 7 multiplied by 2 is 14, which modulo 5 gives me 4. So 12 multiplied by 2, what do you think? Will you get 4? It is 24. So 24 modulo 5 is 4. So that means multiplying also gives them equal. Now let's look at the next property of exponent in modular arithmetic. If A is congruent to B, which means A to the power k will be congruent to B to the power k. That means if we raise both sides by the same power, they will still be congruent. So using this, we can solve these questions that will follow. That is, first question is 3 to the power 16 mod 4. How do we calculate this? Obviously, we are not going to calculate 3 to the power 16. So first step is to reduce the base. So 3 to the power 16 is given. We'll find out 3 mod 4 first, which is in this case 3. Remember, whenever the dividend is less than the divisor, the remainder is the dividend itself. Now let us check some small powers of 3. For example, 3 square, which is 9, modulo 4 will give me 1. Now once you get 1, you are in a very comfortable position because both sides you can raise by any power, and 1 raised by any power will give me 1 only, right? So calculation becomes a little simpler. Now we have 3 to the power 2. How do I bring 3 to the power 16? By raising both sides by the power of 8. So we have this, raising both sides by power of 8. So 3 to the power 16 modulo 4 is going to give me the remainder 1. Now let us see the next question. Find the last digit of 12 to the power 12. Now last digit means modulo 10. For example, last 2 digit would mean modulo 100. Last 3 digit would mean modulo 1000, and so on. So first of all, obviously we'll reduce the base. So we will calculate 12 mod 10, which is 2. Now we will see, we will slightly increase the power. So we can increase both sides by the power 4, because 2 to the power 4 is still comfortable to us, right? So 12 to the power 4 is 2 to the power 4, which is 16. And if we do modulo 10, we're going to get 6. Now I need 12 to the power 12. So obviously both sides need to be raised to the power 3. So 12 to the power 4 to the power 3 gives me 6 to the power 3. Now 6 to the power 3 is 216, which upon division by 10 gives me remainder 6. So which means 12 to the power 12 when divided by 10 will give me 6 as the remainder, which means the last digit of 12 to the power 12 is 6. Now the final question is this. Find the remainder when 5 to the power 61 is divided by 7, which means we have to find 5 to the power 61 mod 7, right? So first step, reduce the base. So we'll calculate 5 mod 7 first, which is equal to 5. Now we will build step by step, which means we will build powers slowly and keep taking mod. So let's see first 5 squared, which is 25, mod 7 gives me 4. Now remember, we can multiply scalar on both sides, but the still congruency sign remains, so it gets preserved. So here, if I multiply 5 on both sides, we are going to get 5 cube, which is equivalent to or congruent to 20 mod 7, which is equal to 6. So once again, let us multiply 5 on both sides. So here I multiply 5 and here I multiply 5. So we get 5 to the power 4 congruent to 30 mod 7. 30 mod 7 is 2. Now let us do one more step. So we multiply 5 over here and again 5 over here. So we get 5 to the power 5 is congruent to 10 mod 7, which is 3. Still we are not close to a comfortable number. So one more step, 5 to the power 6 is congruent to 15 mod 7, and 15 mod 7 is 1. So 1 is a very comfortable number, you already know, because 1 raised to the power anything is still 1. So since we have got 5 to the power 6 and we need a number which is close to 61, so can we raise both sides by the power 10? Yes. So 5 to the power 6 and 1 was congruent. So raising both sides by power 10, we got 5 to the power 60 is congruent to 1 mod 7. Now what? We need 5 to the power 61, which means I need to multiply both sides by 5. So we will get 5 to the power 60 multiplied by 5 on both sides, and we get 5 to the power 61 is equivalent to 5 mod 7, which is equal to 5. That means the remainder when 5 to the power 61 is divided by 7 will be 5. This is a question I've taken from 25-26 sample paper of Applied Mathematics of Class 12 CBSE, and this was a 2 marks question. We have to find the last digit of 2 to the power 100 plus 100 factorial. Last digit means we have to find out modulus 10, right? So we'll find out separately 2 to the power 100 modulus 10. So for this, we will see the base first. So 2 mod 10 is 2. So I'll increase the power on both sides. Let's say I'll increase the power by 5 on both sides. So which means 32 is equivalent to, so 32 when divided by 10 gives me 2. So 2 mod 10. Now increasing the power on both sides by again 5, I get to the power 5 and as well as to the power 5 over here. So we have already seen 2 to the power 25 will be congruent to 2 to the power 5 is 32 mod 10 will give me again 2 mod 10. Remember, I need to reach 100. So now I can increase the power on both sides by 4, because 25 times 4 is 100. So that gives me 2 to the power 100 is congruent to 2 to the power 4, that's 16 mod 10 is basically 6 mod 10, right? And for the last one, where we have to do 100 factorial mod 10. Now 100 factorial can be written as 100 into 99 factorial modulus 10. Again, like addition, multiplication can also be done individually. So 100 mod 10 multiplied by 99 factorial mod 10. Now 100 is divisible by 10. So here the remainder is 0 into whatever number. That is not my concern anymore because over here I am getting 0 only. So the last digit will be the sum of the modulo, which is in this case 6 plus 0, which is 6 is the last digit. So this is my answer over here. Here is a challenge question for you all. Find the last two digits of the number 20 to the power 20. Use modular arithmetic to solve this one. And if you have understood something today, the right thing to do is help someone else understand it too. So share it, stay connected. This is Think Sharp Ali signing off. I'll see you in the next video. Bye-bye.